Looking at number 79 here, hopefully you have a paper copy of this. I don't know how hard it is to read on the video, but when making a long distance call, the first 3 minutes cost $2.80, and after that each additional portion of a minute costs 15 cents. So they ask us to use an inequality to find the maximum number of minutes that you can call for 445. If you're intimidated by the inequality, you can just start out with an equal sign. Try to get your equation written, and then we'll figure out how that inequality should go. You want something on your paper, and usually you can get something on the other side of the equal sign here. Inequality, maximum number of minutes for 445. So this sounds like it's supposed to equal 445. Okay? Let's see. You want your 280. Let's look at this. So you know 445 is basically what your total's supposed to look like at this point. First 3 minutes are 280, and then it's 15 cents a minute. So no matter what, you're going to spend 280. So here's what you're spending. To leave myself enough room. You always spend that 280, okay? But there's more. So to that, we're going to add, this is where our variable comes in. We're going to find out how many minutes, okay? So it'll be 15 cents. Did not want that there. Get this. It's going to be 15 cents per minute. So for the minutes, I'm going to use X. Okay? And notice I kind of skipped over this first 3 minutes of the call. X is minutes. And this might be a little bit hard to see, but this is minutes in terms of cost. Okay, this is minutes in terms of cost, and we know that the cost here is 15 cents a minute. And I'm emphasizing this because there's 3 minutes worth of talking that I'm really not accounting for yet. This 3 minutes of the call, we want it in terms of cost so we can put it in our equation. Okay? So 3 minutes are going to cost 45 cents, right? 3 times 15 is 45. So I guess I'll stick with my green. This is how much money. Over here, everything in green is cost, and over here is cost. So this isn't showing those 3 minutes that I'm going to get when I spend 280. So in order to compensate for that, I'm going to have to put my 45 cents over here. This is the only way to show that I get 3 minutes when I spend that. I don't anticipate you're going to encounter a lot of problems like this, so if it's a bit confusing, you might just ignore the 3 minutes until the end and tack it on your answer. But if you did that, you wouldn't have your 45 here. Alright, so let's combine like terms. We can clean this up, so that would be 490. Oh, we need to take care of our inequality sign here, okay? So let's just rewrite this. We've got 280, 15x, our inequality. You're allowed to spend up to 445 And again, this is compensating for those 3 minutes. So this amount can't be more than this amount. So it has to be less than or equal to this amount. Okay, so there's the inequality sign. And we want to get rid of our 280. Let's see what we've got left here. We've got 15 cents a minute, less than equal to $2.10. And let's get rid of this 15, well, 15 hundredths. So we divide each side by 15 hundredths. This side always cleans up nice and fast. And x less than or equal to, you're going to have to do a little bit of crunching of the numbers. So of course you can't have your decimal in front. You move that 2 places to keep it balanced. You move this 2 places. You tell the world where it is. 15 goes into 21 one time. Bring down your 0. 15 goes into 60 4 times with nothing left over. So x is less than or equal to 14 minutes. And I'll back up just for a second. If you're having a real hard time seeing this first 3 minutes of the call, which turned into that 45 cents, just imagine if you got no time. They just said, hey, look, when you make a phone call, it's going to cost you $2.80 plus 15 cents a minute. If I cover, I guess I'll cover that up. If I cover this up, and think about it, if they're going to charge me $2.80 but not give me any time, and then 15 cents a minute, it's going to come out to $4.45. Okay? But for this, they give me 3 minutes. So I need to show that 3 minutes in my equation somewhere. But I need it in terms of cost. Because all these other numbers are in terms of cost. X is minutes in terms of cost. All right, well, again, that one's a bit more complicated than you're probably going to encounter. For number 81, we're calculating what score a student's going to need. Let me see. So we'll see. There's a chance I'll end up solving this 2 different ways, but I'll start out with what I might call the preferred way. So let's see. We have 3 scores so far. And what must this student score on the 4th test to have an average of at least 85? Again, if you're worried about the inequality sign, just start out with an equal sign. And we'll change it to an inequality sign in just a minute. Okay, 85 is going to be sitting on one side. So again, you can get something on your paper. You find the average by adding the number of scores and then dividing by that number. So the student has 73, 74, oops, that's not supposed to be a times, that's a plus, 98, and what must he score on the 4th test? That's our variable, we don't know, plus x. How many scores are up here now? 1, 2, 3, 4. So this whole thing has to get divided by 4. Now the way I'm showing, it's not the only way to think of it. You could have added up these 3 and just had some number plus x. But you're still going to have to divide by 4. Okay, so let's clean this up a little. 73, 74, 98. Oh, I don't know. So there's 12, 15, 8, 15, 24. So that's 245. So we have 245 plus x over 4, and I never did change my equal sign here. He has to get at least 85. So this average here, this could be bigger than 85, but it can't be any smaller. So greater than or equal to 85. Okay, right now the troublemaker is this 4. So let's get rid of the 4. I'm going to, this 4 is held by division, so I'm going to use multiplication. Incidentally, this isn't the only way to go about cleaning this up, but to me it's the easiest way. I'm going to get rid of that 4. So I will multiply each side by 4. 4 goes into 4 once. Hey, look at that. So we have 245 plus x greater than equal to, and okay, yeah, we have some work here. 85 times 4. Let's see, I'll just do it in my head. 4 times 8 is 32, but that's really 320, and 4 times 5 is 20. So I'm going to say this is 340. Now you want x by itself. Let's get rid of this 245. And let's see how hard this student's going to have to study. That's a 0. Here's your x. There's a 5. What's that? Oh my goodness. 13 and 4. There's a 9. Alright. Better study pretty hard. You need at least a 95 on this. Your score has to be greater than or equal to 95. And I guess that makes sense because if you want an 85, you can see only one of these scores was above it. Both of these scores were below the 85, so you got some work to do there. Okay, so anyway, x is greater than or equal to 95. Alright, so we figured out that x has to be greater than or equal to 95. Alright, and I just want to show that you could check that answer. I'll take this 95 and simply plug it in where the x is, and we'll take it from there. So we'll go with a nice green 95, and we'll put it right where the x is, and then just bring everything else down. I could have plugged it in way up here, but I already added up these 3 digits, and I feel pretty confident that that's 245. So I'm just going to basically put it in right there. Okay. So this would be 245, nice 2, plus 95 over 4, and we'll see if that's greater than or equal to 85. Okay. And I think I'll get this out of my way. There. When I add these together, that would be 250, 340, okay, so 245 and 95. Gives us 340. And then 340 divided by 4. 4 goes into 34 8 times with 2 left over, so that would be 20. 4 goes into 25 times. So our value of 95 checked out just fine.